Hi everyone. In this video, we are going to be doing A Level Maths 9709, Paper 12, Pure Maths 1, October, November 2025. This, this paper is 1 hour, 50 minutes long, so we'll try to finish within that time limit. So let's get started. Okay, so for the first question, we're told to express this quadratic equation in this form. Yeah, so basically this form is the completed the square form. So let's do that. Okay, so first things first, we have to make sure that the coefficient of x squared is 1. So let's do that. So if we draw 9, so x squared minus 4x plus 8 over 9. And now we are going to complete the square for the quadratic equation in the brackets. So start with x, instead of x squared, replace it with x, keep the minus sign, and just take the coefficient of x divided by 2. So yeah, you get x minus 2 squared, and then you subtract it uh, from 2 squared, so 4. And then you add the constant term 8 over. And now let's simplify and expand everything. So minus 4 plus 8 over 9 is uh 30 minus 36 plus 8, that's minus 28 over 9. So now let's expand everything. Sorry. Okay, so it's lagging a bit, sorry. Yeah, so 9 times x minus 2 squared minus 28. And yeah, let's see if it fits the form in here. Yeah, so P is 9, Q is minus 2, and R is minus 28. Yeah, so yeah, this would be a final answer for the first part. Let's head on to the next part. Okay, so for the second part, we are told hence. So we have to use our answer from the previous part. We need to find the set of values of the constant k for which this equation has no real roots. Okay, so if you see the word set of values and no real roots or root set of values, you should know that you're dealing with a discriminant question. So we would have to use b squared minus 4ac for this. And since we're told to find the case where there's no real roots, we have to set our b squared minus 4ac less than 0. So let's do that. So first things first, let's take our equation that we're given and make it into a proper quadratic equation by making one side equals to 0. So just move the k over to the left side, and you would get 9x squared minus 36x plus 8 minus k equals to 0. And now we can evaluate our b squared. Uh, oh wait, sorry. Um, completely forgot that we have to use the answer from the previous part. Okay. All right. So uh, to do this, let's just I don't think we have to use the discriminant here. Let's just start with the completed the square form. That should be easier. And now we're going to isolate x minus 2 squared. so that we can find the value of k for which this has no real solution. So 9 times x minus 2 squared equals to 28 plus k, and x minus 2 squared, that is just k plus 28 over 9. Okay, so now we can ask ourselves, what values can x minus 2 squared be? So obviously, since this is a squared expression, this can only be more than or equals to 0. So if this is negative, there won't be any real roots for x. So we'll set this less than 0. So let's do that. K plus 28 over 9 less than 0. So you just get k plus 28 less than 0. And our final answer, we would get k less than minus 28. So this would be our final answer for the second part. Let's head on to the last part. Okay, so for the last part, we are told to find the exact roots of this equation. So whatever roots we find, we have to express it in the exact form. So we cannot have a rounded version to like 3SF or 1 decimal place. We need to express it in surd form with the denominator rationalized. So let's start. So let's copy down the equation and make one side equals to 0. So that just means moving over the negative 15 over to the left-hand side. So just add 15 on both sides. It'll be 9x squared minus 36x plus 8 plus 15. It'll give you plus 23 equals to 0. And now you may ask, what should we do? Since they tell us to find the exact roots, the best way to do this question would be to directly use the quadratic formula. So let's do that. So our a is equals to 9, b is equals to negative 36, and c is equals to 23. And now we can substitute into a quadratic formula. So x equals to minus b, so that's 36 plus or minus the square root of the discriminant. So discriminant is just b squared minus 4ac. So b squared, that's minus 36 squared. Sorry, it's lagging a bit. Okay, minus 36 squared minus 4 times a. So a is 9, and times c, that's 23. All over 2 times a. So 2 times 9. So you can use your calculator to simplify all this, everything inside the square root. So you would get x equals to 36 plus, hold on, minus 36 squared minus 4 times 9 times 23. You will get square root 468 over 18. And the second solution will be 36 minus 468 over 18. And x would be 36 plus square root 468, that is 6 square root 13 over 18. Same for this, just be 36 minus 6 square root 13 over 18. So just split up the fraction, you will get 36 over 18 plus 6 over 18 times square root of 13. Final answer will be 2 plus 6 over 18, that is 1/3. So square root 13 over 3. And similarly, this will be 2 minus square root 13 over 3. Yep, so these two will be our roots, the exact roots for this equation. And yeah, we can head on to the next question. Okay, so for the second question, we are told to find the term independent of x. So what this means is that we need to find the constant term in the expansion of this binomial expansion. Okay, so I know at first it'll be very tempting to expand it as much as you can until you get the constant term. However, there is a much more efficient way to do this that involves using a formula that you can easily derive from the formula sheet. So if you take a look at your formula sheet, you will see that a plus b of n. Sorry, it's lagging a bit. Give me a while. Oh, a plus b to the power of n. You start off with a to the power of n. Then the next term would be n choose 1. Oh my. Sorry, something is happening. Uh, okay. Yeah, then you'll get n choose 1 times. Sorry, it's acting up a little bit. Um, okay, so n choose 1 times a to the, wait, a to the power of n minus 1, then times b to the, okay, give me a while. Okay, sorry everyone. So as I was saying, um, the formula goes like this. So the first term, the second term will be n choose 1 times a to the power of n minus 1, and then times b to the power of 1. And the next term would be n choose 2 times a to the power of n minus 2 times b to the power of 2, and so on and so forth. So we can express this independently as the formula for a general term. So this would be the formula for the r plus 1 term, and it is equal to n choose r times a to the power of n minus r times b to the power of r. So this is the general formula that we are going to be using. So let's substitute n and r, n and a and b into this formula. So for our expansion, n is 6, so 6 choose R, and then a is 2x squared, so 2x squared to the power of 6 minus R, and our b is minus 3 over x, so minus 3 over x to the power of R. And now our goal is to isolate all the x terms all the way to the end of this expression. So let's do that. So first things first, in order to simplify this, we can see that we have a power inside the bracket as well as outside the bracket. So how do we combine these powers? Well, we can use this law of indices that you might have learned before in your IGCSE, your O levels. Yeah, you would just get a to the power of b times c. So similarly, here we are going to, oh, and before that, this power, you have to spread it over to the constant term as well as the x term. So this would be 2 times 6 to the power 6 minus r times x squared times 6 minus r. Okay, and now to expand this, this expression is in this form, a over b to the power of n, which is equals to a to the power of n over b to the power of n. So yeah, and we also have a constant term in front of our 3 over x, so we also have to move the power to that constant term as well. So this would just be minus 1 to the power of r times 3 over x to the power of r, which we can rewrite as 3 to the power of r over x to the power of r. Okay, now let's move all the x terms to the very end of the equation. So let's move the constant term here. Okay, and you have x squared times 12 minus 2r divided by x to the power of r. So we can just simplify that as 12 minus 2r minus r because of the law of indices. So we have the same base to the power of b divided by the same base to the power of c. We can rewrite that as a to the power of b minus c. Same for multiplication, except the sign would be plus. So for this, you would have to know your laws of indices from your previous study. Okay, so let's simplify everything one last time. And then this expression, since they have the same power, we can just multiply minus 1 and minus 3. This will just give us minus 3 to the power of r. And then finally, we'll have an x power as x to the power of 12 minus 3r. And yeah, this is our general term formula. And now, sorry. Yeah, so now we can find our term independent of x, which is our constant term. So to find that, we have to know that the power of x, since it's a constant term, this should just be equal to 0. Since x to the power of 0 just gives you 1, so we just equate it to 0 and solve for r. So you would get 3r equals to 12, and r would be equals to 4. And now we can just substitute this back into our formula, term independent of x. So you get 6 choose 4 times 2 to the power of 6 minus 4 times minus 3 to the power of 4 times x to the power of 0. Or you don't have to include the 0 because it's going to be 1 anyway. So just type it into a calculator. 6 choose 4 is 15 times 2 to the power of 6 minus 4. Get 60 times negative 3 to the power of 4. You would get 4,860 as your final answer. And yeah, this would be the final answer for this question. Let's head on to the next question. Okay, so for this third question, for the first part, we are told that the graph of y equals to fx is transformed to the graph of y equals to f3x plus 2. And we have to describe fully the two transformations which have been combined to give this graph. So we have to identify the transformations that transform the graph from y equals to fx to y equals to f3x plus 2. Okay, so first of all, let's see what has been multiplied or added to the graph. So let's start with y equals to fx. So in order to make this, we can see that that instead of x inside the bracket, it's fx. So that's the first change. Every x term is multiplied by 3. Yeah, so what this means is that the graph has been stretched horizontally. So horizontal stretch, and if the function has been multiplied outside, so instead of f3x, it's 3fx, it would be a vertical stretch. So yeah, this is a horizontal stretch. And as for the scale factor, for horizontal stretches or horizontal translations, it's always the opposite. So in here, since the x term has been multiplied by 3, it would be 1 over 3, not 3. So the scale factor is 1 over 3. Similarly, if it's been translated horizontally by plus 3, so you add plus 3 to x, it would have been moved by negative 3 units to the left, not the right. Yeah, so it's like the opposite for x. Okay, and then to get our final equation, just add 2. And what happens when we add 2 to the whole function instead of just x? Well, sorry, my it's lagging again. Yeah, let me just wait for a while. Okay, so as I was saying, what happens if we add a number 2 outside the function instead of inside the function? Well, the translation would be just vertical, so just move up or down. And in this case, since we added 2 to the function, the graph would move 2 units upwards. So mathematically, this would be expressed as a translation by a vector. So it is not moved horizontally at all. So the top number would be 0. And the bottom number would be the vertical translation, which is 2. Sorry, it's taking a while. Yeah, so as you can see, it's translation by 2. Actually, let me pause the recording for a while because it's getting quite laggy. Okay, sorry for the delay, everyone. So yeah, this is our final two translated transformations. So first is a horizontal stretch by scale factor 1/3 and translation by the vector 0 and 2. So let's write that down. So total stretch by scale factor. So 1/3. And translation by 0 to. And yeah, this would be our final answer for the first part of this question. Let's head on to second part. Okay, so for the second part, we are told that another graph has this equation y equals to gx. And this time we are told the transformations that it undergoes. So first, it is stretched by scale factor 3 in the y direction. So it's a vertical stretch with scale factor 3. And then it has been reflected in the y-axis. So by that, they mean initially the graph was something like this. And then after that, it's reflected across the y-axis like this. Okay? Yeah, so this is what they mean by reflected in the y-axis. And so using this, we need to write down the equation of the transform graph in terms of the function g. Okay, so what happens to the equation when we stretch it vertically? So you just have to multiply the equation by the scale factor. So first, um, by stretching it in the y direction, scale factor 3, our equation would change to 3gx. So similarly, if you stretch it in the y direction with scale factor 1/3, it would be 1/3gx. And then now, what does it mean when it's reflected in the y-axis? So reflection in the y-axis It's reflected horizontally. And what do we associate? Anything, uh, any transformation that is horizontal, we associate it with the x direction. So reflection is just multiplying the equation of the graph by -1, either outside the function or inside the function. Since it's horizontal, we're going to multiply -1 inside the function. So our final equation would be y equals to 3g bracket minus x. And so this would be our final answer for this last part of this question. Let's head on to the next question. Okay, so for the fourth question, we are given the equation of a curve in terms of dy dx. So dy dx is k x cubed plus 2 over x squared, where k is a constant. And we're also told that the curve passes through the point S. So we're also given the coordinates of S as well. And the gradient of the curve at S is 65 over 2. Okay, so for the first part, we need to find the value of k. Sorry, my pen is lagging. Okay, give me a while. I need to pause the recording again. Okay, so sorry for the delay. As I was saying, the question also says the gradient of the curve at S is 65 over 2. So for the first part, we're told to find the value of k. Okay, so to do that, since it's only 1 mark, we're not going to think of integrating our dy dx expression, to get the equation of the curve. Instead, we're going to focus on the last piece of information that we're given, the gradient of the curve at S. So you must know that the gradient of the curve at any given point is given by the dy dx function at the when at the dy dx function when you substitute the respective x coordinate of that specific point. So we know the x coordinate of s, which is 2. So by substituting x equals 2 into dy dx, we can equate it to 65 over 2. So let's do that. So k times 2 cubed plus 2 over x squared. So 2 over 2 squared, that is equal to 65 over 2. Okay, and then 2 cubed, that is 8k plus 2 over 4, that is half, equals to 65 over 2. Then you minus half from both sides. You would get 64 over 2, which is 32. And then you divide 8 on both sides, you will get 4 as your final answer. Yeah, so this would be the final answer for the first part of this question. Let's head on to the second part. Okay, so for the second part, we're told that the coordinates of a point T on the curve are 1, comma, T. So the y coordinate, they just expressed it as T and our x coordinate is 1. And using this, we need to find the value of T. Okay, so in order to do this, we first have to know the equation of the curve in terms of y so that we can substitute 1 into our equation, then we can get t. So let's try to find the equation in terms of y. So since we're given dy dx, we can just integrate our dy dx to get the equation of the curve in terms of y. So let's do that. So y is just the integral of ax cubed plus 2 over x squared dx. And in order to make this easier to integrate, we're going to make it a negative power. So we get kx cubed. Oh, sorry, we already know what the value of k is. It's 4. Yeah, so 4x cubed plus 2 times x to the power of negative 2 dx. So now we're ready to integrate. So first we're going to integrate this. So to integrate this, you can leave the 4 outside and just integrate x cubed. So to do that, just add 1 to the power. So x to the power 4, and you divide by the new power. Same for this. You leave the 2 outside and then you just integrate x to the power of negative 2. So you add 1 to here, then you get x to the power of negative 1 divided by the new power of negative 1. And don't forget to add your plus c, since this is an indefinite integral. Okay, so simplifying, we would get x to the power of 4 minus 2 times x to the power of 1 plus c. Okay, so to find our c, we need to know a point where we know both the x and y axis, and at the very beginning of the question we are given the coordinates of s, 2 and 20. So let's substitute that. So sub x equals to 2 and y equals to 20. So this would be 2 to the power of 4 minus 2 times 2 to the power of negative 1 plus c equals to 20. And then you can just use your calculator to find out what c is. So 20 minus 2 to the power of 4 plus 2 times 2 to the power of negative 1, we would get 5. So final equation of the curve in terms of y, it's y equals to x to the power of 4 minus 2 over x plus 5. Okay, and now we're going to find t, we're just gonna simply substitute x equals to 1 and y equals to t. So t would just be 1 to the power of 4 minus 2 over 1 plus 5. So this would just give us 4. So yeah, t is equals to 4. That would be all for this part of the question. This was the entire question. Let's head on to the next question. Okay, so for this question, we are given a curve and we're also given the equation of it, which is y equals to 4 times x to the power of half minus x. We're also told that the curve has a maximum point where x equals to a and crosses the x-axis at the point with coordinates b and 0. So it's all shown in the diagram. So this is the maximum point they're referring to. And this is the coordinates of the point where the curve crosses the x-axis. Okay, and then the shaded region is bounded by the curve, the line x equals to a, and the x-axis. Yeah, so it's all shown in the diagram. So using that, for the first part, we're told to find the value of a. Okay, so to find the value of a, we can use the fact that the x-coordinate of the maximum point is a. And what do we know about maximum points? Well, we know that maximum point is also a stationary point. Sorry, it's lagging a bit again. Okay. Let me just, okay, stationary point. Yeah, so maximum point is a stationary point. So, and at every stationary point, the dy dx at that point is always equal to 0. So we can start out by finding dy dx. So yeah, we just have to differentiate the equation of the curve. Okay, so that's 4 times x to the power of half. Oh no, half minus x. And then we differentiate this first. So again, since 4 is a scalar, just leave that alone and differentiate x to the power of half. So you bring down the existing power, half times x, and then you minus 1 from the existing power. So minus 1 plus half, you get minus half. And then minus the derivative of x, which is 1. So simplifying everything, you would get 2 times x to the power of half minus 1. And simplifying further, you will get 2 over square root x minus 1. Yeah, so this is our expression for dy dx. And now we can substitute 0 into dy dx to get our x-coordinate of the maximum point, which is a. So yeah, you would get 2 over square root x equals to 1. And then you get square root x equals to 2. And x would just be 2 squared, which is 4. So hence, we can say that a is equals to 4. And yeah, this would be a final answer for the first part. Let's head on to the next part. Okay, so for the second part, we are told to find the exact area of the shaded region. Okay, so let's take a look at a diagram. So the shaded region is basically bounded by the limits A and B, and it's under the curve and is bounded by the x-axis. So the formula that we're going to use is the integral of the curve with limits B and A. So B and A, and the equation of the curve 4 times x to the power of half minus x dx, since it's bounded by the x axis. Okay, now how do we determine our limits, the exact value? So we already determined what A is. A is 4. And to determine what B is, well, we just substitute the y coordinate of B, and then we find the x coordinate, we'll get B. So let's do that. So 4x to the power of half minus x goes to 0. So to solve this, let's re-express x to the power of half as 4 times square root x minus x. So x, we can re-express it as square root x squared. And now you can see we have a hidden quadratic in square root x. So we can just factorize square root x, then get square root x bracket 4 minus square root x equals to 0. And then you'll get square root x equals to 0. 4 minus square root x equals to 0. Square root x equals to 4. And x is equals to 16. And here you'll get x equals to 0. So we would have to reject 1. As you can see, b is obviously not 0, so we'll reject that. And hence, b is equals to 16. So now we can evaluate our definite integral. 16, and the lower limit is 4. For x to the power of half minus x dx. Okay, so to integrate this, leave the 4 alone and integrate x to the power of half. So you would get x to the power of 3 over 2. You add 1 to the power and you divide by the new power 3 over 2. And minus the integral of x. So you add 1 to the existing power, you get x squared divided by the new power 2. And don't forget to put your limits to the side and you substitute them later. Okay, let's simplify our indefinite integral first. So 4 divided by 3 over 2, that's 8 over 3 times x to the power of 3 over 2 minus x squared over 2. And now we're ready to substitute our limits. So let's substitute 16. So 8 over 3 times 16 to the power of 3 over 2 minus 16 squared over 2. Now we substitute 4 into here. So 8 over 3 times 4 to the power of 3 over 2 minus 4 squared over 2. Okay, now just type all this into your calculator. You would get 88 over 3 units squared. And yeah, so this would be a final answer for this part, as was the entire question. Let's head on to next question. Okay, so for this question, for the first part, we're told to sketch this graph, y equals to 3 sine x plus 2, for this given domain from 0 to 2 pi. Okay, so to sketch this, we are going to first figure out what transformations this has undergone from the curve of y equals to sine x. So as you can see, in order to get this curve, they first multiply 3 into sine x. So that means it was vertically stretched by scale factor 3. So I'm just going to write it here. Vertical stretch scale 3. Yeah, I'm not gonna write the factor, and then they added 2. So if they added outside the function, not within x, so then it has been displaced vertically. So it's translated by 0, 2. Okay, so I'm just gonna draw the graph of sine x um, in broken lines. So the graph of sine x looks something like this. So it's 0 here, and then it continues all the way until there. So this is the graph of sine x. So now we're going to take all our translations into account. So first, it's been translated by 0, 2, so it would be vertically displaced upwards by 2 units. So this would be the axis instead. Yeah, we're going to erase the sine x graph, and it is also much taller, so it's like this instead of this. Okay, so using that, we're going to sketch our graph. So this is 2. Let me erase that as well. Okay, yeah, so be something like this, and also like this. Sorry. Okay, yeah. Yeah, this is good enough. So this is the point, pi, and 2, and 2 pi. Yeah, so this is our curve. Y equals to 3 sine, 3 sine x plus 2. Yeah, so yeah, this would be our final answer for this part. Let's head on to the next part. Okay, so for this part, they told us to determine the number of solutions, not the solutions, in the interval 0 to pi for each of the following equations. So the first equation they gave us is 3 sine x plus 2 equals to x. Okay, so first of all, we realize that this equation cannot be solved directly. So we are going to have to use the graphical method to solve this equation. So to solve it, we have to figure out what graphs we have to draw in order to get the number of solutions. So we have already drawn y equals to 3 sine x plus 2. And to figure out what's the other graph we're going to draw, just look at the other side of the equation. We'll get y equals to x. So we're going to draw y equals to x. So I'm going to draw it in black. Yeah, so we're going to draw it as accurately as we can. Uh, yeah, so I'm going to see where, so pi over 2, that's half pi. So it'll be somewhere here and here. Okay, so yeah, so this is y equals to x. So as you can see, there is only one point of intersection. So yeah, we can say that there's only one solution. Okay, now let's do the same for the next one. 3 sine x plus 2 equals to 5 minus x. So we're going to use the same approach as the previous one. Figure out what graphs you have to draw. So obviously we need to draw this and this. So we're going to draw y equals to 5 minus x. So to draw that, just substitute the values of x. So I'm going to sub x equals to 0. You will get 5. So 3, 4, 5. 5 would be somewhere here. Again, I'm gonna draw it in black. So this is 5. Uh, okay, now we're gonna substitute pi over 2 into x. So this is 3.42. So for we can say it's somewhere here. So now I'm gonna join those two lines up. Okay. Yeah, so yeah, this is y equals to 5 minus x. Okay, so you can see that there is 3 points of intersection approximately. Yeah, so we can say that there are 3 solutions. And yeah, this would be our final answers on this part as well as the entire question. Let's head on to the next part. Okay, so for this last part, we are told to solve this equation for x between 0 and 2 pi. Okay, so first of all, let's just copy down the equation. Sorry. Sine x plus 2 equals to 5 cos square x. Uh, wait. Cos square minus 1. Okay, so as we can see, there's a cosine square in this equation, and we have a sine x. So it's best for us to express this equation in terms of sine only. So to do that, we can use our trig identities. Yeah, so the trig identity we're going to use is cos squared plus sine squared equals to 1, and we'll make cos squared the subject, which would just be equals to 1 minus sine squared theta. So we're going to use that. So 3 sine x plus 2 equal to 5 times 1 minus sine squared x. Sine squared x minus 1. And yeah, now we're going to expand everything out. Five minus 5 sine square x, sorry, -1. Okay, now we're going to move everything to the left-hand side of the equation and make the right-hand side equals to 0. So doing that, we'll get 5 sine square x plus 3 sine x, 2 plus 1 minus 5. We get a -2 equals to 0. Okay, now we have a quadratic in terms of sine x. So I'm going to try factorizing it. So 5, 3 minus 2. Okay, so factorizing it, we get 5 sine x minus 2 times sine x plus 1 equals to 0. And now let's solve for sine x. So 5 sine x minus 2 equals to 0. 5 sine x equals to 2. And sine x equals to 2 over 5. And the second one is sine x plus 1 equals to 0. And you'll get sine x equals to -1. Okay, so now let's draw our unit circle and label all the 4 quadrants. So this one be A, this one be S, this one be T, and this one be C. So let's first notice which quadrants our domain covers. So this is 0, pi, and 2 pi. So it covers all 4 quadrants. And now let's identify which quadrants are positive for sine and which are negative for sine. So this is positive for sine, this one is this, and this is negative, and this is negative. So to solve sine x equals to 2 over 5, x can be in either of the 2 quadrants, so either this or this. We're going to solve for this quadrant first. So x in this quadrant is going to look something like this. It's going to be an acute angle. So to get that, just directly take sine inverse 2 over 5. So to take that, make sure your calculator is in degree mode, and you would get 0.412 to 3SF. And to get our second value for x, it would be in the second quadrant, and it would look something like this. It would be an obtuse angle. So to obtain that, you have to subtract pi, which is 180 degrees from the basic angle. And the basic angle is the same as the acute angle we got in our first quadrant. So pi minus sine over inverse 2 over 5, you would get 2.73 to 3SF. So yeah, these are our 2 answers, and we're gonna solve sine x equals -1. Well, for this, there's going to be 2 values. Wait, no, actually, there's only 1 value, which is in here, so just 3 over 2 pi. And for this, you need to know the graph of sine x, which we have previously sketched in here. And -1 is somewhere here when x equals to 3 over 2 pi. So yeah, now check that all the answers, they fit the range. Yep, they do. So yeah, these would be our final three answers for this part. And we have come to the end of this question. Let's head on to the next question. Okay, so for the seventh question, we're told that the coordinates of points P and Q are 1, 1 and 7, 11 respectively. And we're also told that the line segment PQ forms a diameter of a circle. So basically, PQ is the diameter of a circle. Yeah, it's not perfect, but you get the idea. And hence, the midpoint of PQ would be the center of that circle. So for the first part, we need to find the equation of the circle. Okay, so first things first, let's find the center of the circle. So as I said just now, it would just be the midpoint of PQ. So to find that, sorry, just take the x coordinates of P and Q, add them up. So 1 plus 7, and then you divide it by 2. Now do the same for the y coordinates. So 1 plus 11 divided by 2, we'll get 4, comma 6. So this is the coordinates of the center of the circle. Now we're going to find the radius of the circle. So to find the radius, just find distance from the center of the circle to either P and Q. I'm just gonna find it from P. So yeah, to do that, you would find the difference between the x coordinates of P and the center. So I'm gonna take P first. So 1 minus 4. And then you square it, and then you add it with the difference of the y coordinates. So you take 1 minus 6 squared. And don't forget to square root the entire thing for the radius. So 6 squared, you would get square root 34. And your r squared, your radius squared, would just be 34. Okay, and now we are ready to form the equation of our circle. So the equation is x minus the x coordinate of our center. So that's 4 squared plus y minus the y coordinate of the center, which is 6 plus r squared, radius squared, so 34. And yeah, this would be our final answer for the first part. Let's head over to the second part. Okay, so for the second part, we are told to find the equation of the tangent to the circle at point Q. Okay, so let's go back to the sketch we made. So the tangent is basically a line that only passes through that point and nothing else. So this is the tangent. And one property of the tangent that you must know is that it is always perpendicular to the radius of the circle from that point. So this is center and Q. So the line connecting C and Q is perpendicular to the tangent at point Q. So using that, we are going to find the gradient of the tangent. So first things first, let's find the gradient of CQ, center and Q. Sorry. Uh, so center and Q, just take the differences in the y coordinates. So take the y coordinate of the center, and then you subtract it from the y coordinate of Q, which is 11. Sorry, it's a bit laggy. And then you do the same for the x coordinates. So take the x coordinate of the center, and then you subtract it from the x coordinate of q. Sorry, it's a bit laggy. Okay. And you would get 6 minus 11 is 4 over 7. You'll get 5 over 3. Sorry, it's a bit laggy. Okay, 5 over 3. So that's the gradient of the line CQ. Now we can find the gradient of the tangent by making use of the fact that they are perpendicular. So for any two lines that are perpendicular, the product of their gradients will always equal to -1. So using that, we can find the gradient of the tangent by dividing -1 with the gradient of the line CQ. So you get -1 over 5 over 3. You'll get -5 divided by 5 over 3. You'll get -3 over 5. So now we can form the general equation of the tangent. So this would just be y equals to -3 over 5x plus c. And to find the full equation, we're just going to substitute the coordinates of point Q. So -3 over 5 times 7 plus c, that's the x coordinate of Q, and equals to the y coordinate of Q. And now we're just going to simplify everything. Just press a calculator. You would get 76 over 5. So yeah, we can leave this as a final answer. Y equals to -3 over 5x plus 76 over 5. Or if you don't want any fraction, just multiply both sides by 5. You would get 5y equals to -3x plus 76. Yeah, so either of these two could be the final answers for this part. Let's head on to the next part. Okay, so for this last part, we're told that the other point of the circle with x coordinate 7 is r. And now we need to find the coordinates of the points of intersection of the tangent at Q with the tangent at R. Okay, so in order to do this question, let's draw the sketch that we made in part A. Yeah, so point Q is somewhere here, and then this is the line, x equals to 7, and this is point R. And then this is center. So this is C, and this is R. And yeah, this would be the tangent at Q. So this tangent Q. And this would be tangent at R. So yeah, this is the points of intersection that we need to find. So this is perpendicular, this is also perpendicular. Yeah, all right. So in order to find the equation, in order to find the points of intersection, we need to know both the equation at the tangent at Q as well as the tangent at R. So we're gonna try finding the equation of the tangent at R. So in order to do that, we need to first know the coordinates of R. So we know the x coordinate of 7, but we don't know the y coordinate. So in order to do that, we're going to use the equation of the circle. So just substitute x equals 7, so 7 minus 4 squared plus y minus 6 squared equals to 34. And now just isolate y minus 6 squared equals to 34 minus 7 minus 4 squared, get 25. And then take the square root on both sides. You will get square root 24, which is plus or minus 5. And now we can find both values of y. For plus 5, that would be 5 plus 11, 5 plus 6, which gives you 11. And for negative 5, you'll get negative 5 plus 6, which is 1. Yeah. So we know that the y coordinate 11, that actually belongs to Q. So we will reject it. Sorry. And hence this would be the y coordinate of R. So we can write down R is 7, 1. Yeah. So now we can find the what do you call the gradient of CR. So we're gonna do that. So MCR, take the difference in the y coordinate. So we'll take the y coordinate of the center. So that is 6, and then minus 1, and then 4, which is the x coordinate of the center, and we'll minus it with the x coordinate of R. So that just gives us 4 minus 7, which is minus 5 over 3. Yeah. And using the property that the product of the gradient of the tangent as well as the gradient of CR is -1, you can find the gradient of the tangent of R by dividing -1 with the gradient of CR. So -1 over negative 5 over 3, you would get 3 over 5. Yeah, let's see. Yep, you'll get 3 over 5. So we can make a trial equation for the tangent at R, which is just y equals to 3 over 5x plus c. And to find c, we can just substitute the coordinates of R into x and y. So 3 over 5 times 7 plus c equals to 1. You will get c is equal to 1 minus 3 over 5 times 7, which is minus 16 over 5. Okay, so hence this would be our final equation, y equals to 3 over 5x minus 16 over 5. And if you don't want any fractions, you can multiply by 5 on both sides. You'll get 5y equals to 3x minus 16. So this is the first equation for R, and then for Q, that is 5y equals to minus 3x plus 76. Minus 3x plus 76. So this is for Q. Yeah. So we can equate equation 1 and 2. Then we'll get 3x minus 16 equals to minus 3x plus 76. So we'll move all the x's to the left-hand side. So add 3x to both sides. This will go away. So 3x plus 3x, that's 6x. And then we will move all the constants to the right-hand side. So add 16 to both sides, you'll get 76 plus 16, which is 92. And then x would just be 92 divided by 6, which is 46 over 3. And to get our y value, just substitute x equals to 46 over 3 into 1. So you'll get 5y equals to 3 times 46 over 3 minus 16 equals to 30. And then y would just be equals to 6. Yeah, so we got both our x and y coordinates for the points of intersection. So the final answer would be 46 over 3, comma 6. Yeah, so this would be our final answer for this last part as well as the entire question. Let's head on to the next question. Okay, so for this question, we are told that the first 3 terms of a geometric progression are A, B, and C, respectively, where A, B, and C are positive constants. And we also told that the first 3 terms of an arithmetic progression are A, B, and negative 3C, respectively. So for the first part, we are told to show that this equation is true. Okay, so a geometric progression is like this. So to get your next term, you multiply it by a common ratio, and then you'll get B, and then you multiply by the same common ratio to get C. So this is the geometric progression. And for the arithmetic progression, to get B from A, you add it with a common difference D to get B, and to get C, you also add D to B to get negative 3C. Okay, so yeah, we're gonna make equations in terms of R and D. So since B is equals to A times R and C is equals to B times R, we can agree that R is equals to B over A, and R is also equals to C over B. So we can equate these two to get B over A and C over B. If we cross multiply, we'll get B squared equals to AC. So this is our first equation. Now we'll make an equation in terms of D. So B minus A is equals to D, and minus 3 minus B equals to D. Now we can equate them. So B minus A equals to minus 3 minus B. Okay, so let's move all the B to the left-hand side and all the other terms to the right-hand side. So add B to both sides, this will be gone. So you'll get 2B, and then add A to both sides, this will be gone. Then you'll have A minus 3C. Okay, so let's make B the subject. So B would just be A minus 3C. Sorry, A minus 3C over 2. So this is equation number 2. So we can sub 2 into 1. We'll get A minus 3C over 2 squared equals to AC. So this is A squared minus 2 times A times 3C. So that is 6 AC. Yeah. Minus 2 times A times 3C plus 9c squared over 4 equals to AC. And then you multiply by 4 on both sides and move that to the other side, you'll get a squared minus 10 AC plus 9c squared equals to 0. Yeah, so we can write shown. Yeah, so this would be a final answer for the first part. Let's head on to the next part. Okay, so now we are told that A equals to 9 and C takes the smaller of its two positive values. So for the first part, we are told to find the sum to infinity of the geometric progression. Okay, so first things first, let's try to find the values of A, B, and C. Okay, yeah, so let's find the value of C first. So A squared is 9 squared minus 10 times A, which is 9, C plus 9C squared equals to 0. And then simplifying, we'll get 9C squared minus 90C plus 81 equals to 0. So as you can see, all the coefficients are multiples of 9, so you can just divide both sides by 9, get C squared minus 10C plus 9. So now let's factorize it. You can do it using calculator, or you can also use the quadratic formula. So we got C minus 9 times C minus 1 equals to 0. So you get C minus 9 equals to 0, you get C equals to 9, and C minus 1 equals to 0. You get C equals to 1. And they already said C takes the smaller of its two positive values, so we're going to reject C equals to 9. So our final answer would be C equals to 1. Okay, now we can find our B. So we already know B squared is AC, so B squared, just multiply A times C, which is 1, which is 9, and then B would just be square root 9, which is 3, which is, yeah. So B would be equals to 3. All right, so now we're ready to find the sum to infinity. So just refer to your MF19. So the sum of infinity formula is here. So it's just A, which is the first term, over 1 minus R, where R is the common ratio. So we need to know our common ratio, and we've already established that it's just B over A. So B over A, that's 3 divided by 9, which is just 1/3. So hence, sum of infinity would just be the first term, which is A. So A is 9 over 1 minus R, so 1 minus 1/3, which is equal to 27 over 2. Yeah, so this would be our final answer for the first part. Let's head on to the second part. Okay, so for the second part, we are told to find the sum of the first 20 terms of the arithmetic progression. Okay, so let's look at the formula for finding that. So as you can see, there's actually two formulas for finding the sum of the first n terms. So this one would require you to know the last term, but since we don't, we're going to use this formula instead. So let's copy it down. So Sn equals to half times 2a, wait, 2 half time, or half n, sorry. So half n times 2a plus n minus 1 times d. So this is the formula that we're going to be using. So let's figure out what our d is. So we've already made an equation in terms of d in the previous part. So b minus a, that's d. Okay, so b minus a. So b is 3 and then a is 9. So 3 minus 9, that is minus 6. Yeah, minus 9 plus 3, and that's minus 6. Okay, so we have D, and then A is, well, just A. Okay, so yeah, 9. So hence, S20 would just be half times 20 bracket 2A, which is the first term, which is 9 plus 20 minus 1 times D, which is negative 6. Okay, so just type it into your calculator. Okay, let me see if I got all the brackets correct. Okay, yeah, so the final answer we got is negative 960. Yeah, so this would be the final answer for this last part as well as the entire question. Let's head on to the next question. Okay, so for this question, we are given the function f and it's defined as such, and the domain given is x more than 2. Okay, so we need to find an expression for the first part and find expression for f prime x, and hence determine whether f is an increasing, decreasing function, or neither. Okay, so let's evaluate f prime x first. So to do that, we're going to re-express this equation as 4 times 3x minus 6 to the power of negative 2 and plus 1. Yeah, so we can just leave it alone. 3x minus 6 to the power of negative 3. And now we're ready to differentiate. So f prime x, we have to differentiate fx. 4 times 3x 6 plus x 6 3. Okay, and now we'll differentiate this first. So we have a scalar term, so we can just leave that alone. So we only have to differentiate 3x minus 6 to the power of negative 2. So yeah, bring down the old power, which is negative 2, and minus 1 from the old power, that you get minus 3. And then, according to the chain rule, you also have to multiply by the derivative of the inner function, which in this case is 3. Yeah. And let's do the same for 3x minus 6 to the power of negative 3. So you bring negative 3 forward, times 3x minus 6 to the power of minus 3 minus 1, which is minus 4. And then you multiply by the derivative of the inner function, which is also 3. Yeah, so you would get 4 times negative 2, that's minus 8, times 3, which is minus 24, times 3x to the power of negative 3 minus 3 times 3, which is minus 9, times 3x minus 6 to the power of negative 4. Okay, so let's re-express this. So minus 24 over 36x minus 6 to the power of 3 minus 9 over 3x minus 6 to the power of 4. Okay, so okay. All right. Let's factorize minus 3 over 3x minus 6 cubed. And then you would get 8 plus 3 over 3x minus 6. Okay, so to determine whether this is an increasing function, decreasing function, we have to find out whether f prime x, we have to find the domain of f prime x. I mean, sorry, we have to find out the range of f prime x. So whether it's less than 0 or more than 0. If it's less than 0, it's a decreasing function. If it's more than 0, it's an increasing function. So, so this part, so 3x minus 6, so x is more than 2. So 3x minus 6 is always more than 0. So 3x minus 6 to the power of 3 is positive. So minus 3 over positive number, you will get negative. And then this 3x minus 6, as I said, is more than 0. So it's positive. So 3 over something positive, you get positive. Positive plus positive, you'll also get positive. So negative times positive, you'll get negative. So we can say that fx is less than 0. Hence, it is, sorry, it is a decreasing function. Yeah, so this would be our final answer for this first part. Let's head on to the next part. Okay, so for the second part, we need to state whether f inverse exists, and we need to give a reason for our answer. Okay, so for inverse function to exist, so how an inverse function is graphed. So let's say this is fx, and we want to find the graph of f inverse x. We just reflect it over the line y equals to x. So yeah, for this case, it exists. And another condition is that it should meet the domain and range requirements. So its domain has to be within the range of fx, and its range has to be within the domain of fx. So if it's not within, then it also doesn't exist when we reflect it over the line y equals to x. So in our case for fx, it exists. So f inverse exists. So we can say since it's a decreasing function, so so it's a decreasing function, so it's something like this. And when you reflect it over the line, it will be something like this. And we can see that the domain and the range, they kind of fit because they're kind of swapped, right? Yeah, so we can say because it is, sorry, it is a decreasing function. Yeah, so yeah, this would be the answer because if it was an increasing function, so if it was something like this and then you reflect it, yeah, it wouldn't really like match. Yeah, so yeah, that's why F inverse exists. So yeah, this would be a final answer for part B. Let's head on to the next part. Okay, so now we're given this function g and we're told it's equal to 4x minus 3 for x more than a. So part C, we need to find the range of g in terms of the constant a. So the range of a function is basically like how big the function can get given the values of x it can exist for. Yeah, so we basically need to find the range for gx. So in order to do that, let's start off with the domain. X is more than a, and we will have an inequality in terms of 4x minus 3 more than or less than something. So to do that, we multiply both sides by 4 first, and then we subtract 3 from both sides. So hence, we can say that the range of G is more than 4a minus 3. Okay, so yeah, this would be a final answer for this part C. Let's head on to the next part. Okay, so for the last part D, we need to find the set of values of A for which the composite function fg exists. So for composite function fg to exist, so fgx, the range of g has to fit within the domain of f. So we already know the domain of f, which is 2. So gx, it has to be more than 2. Yeah, so gx has to be more than 2. Okay, um, so this it so this cannot be 2 or less. Yeah. So yeah, 4 minus 3a, uh, it has to be more than, wait, yeah, so as I said, the domain of f has to be within or equal to the range of gx. So gx, it has to be more than 2. So that means um yeah, so first we're gonna find the values of a for which this would be not allowed. So for a is 5 and then a would be more than 5, more less than or equals to 5 or 4, and hence our set of values would be a is more than 5 or 4. And to double check this, we are going to substitute back into a. like for gx. So 5/4 minus 3, we get 2. So gx more than 2. Okay. Let's try 6/4. Yeah, then we'll get gx is more than 3. Okay. Yeah. All right. Yeah. So yeah, it's within the range. Yeah. So yep, this would be our final answer. Yeah, if you ever get confused like this type of question, just choose one inequality sign. So you can choose more than, and then you can substitute the values of A that are within the range that you have found. And then if they don't meet the requirement, just flip the inequality sign. Yeah, so this would be a final answer for this part as well as the entire question. Let's head on to the last question. Okay, so for the last question, we're given this diagram. So it shows a circle with the center A. So this is the circle and radius R passing through the points B, C, and D. So B, C, and B, C, and D. And then there's also a larger circle of radius S that is center C. So this is the larger circle, and it passes through B and D. And the length BD is also S. So for the first part, we need to show that S is equals to square root 3R. Okay, so in order to show that, we have to express S in terms of R. So the way we do that is to look for some familiar shapes. So one thing, so I realized that B, C, and D, since they all have the same sides, they actually form an equilateral triangle. And we know that each angle at each vertex of an equilateral triangle is equals to 60 degrees. So yeah, so B, and since the line BA cuts these perfectly into half, we can say that the angle DBA is actually 30 degrees. And using that, we can find the length of B until here using trig. Yeah, so yeah, so the length of this side is just half of S, so it's just S/2. So hence we can equate S/2 with, so this is a right angle triangle, and this side is opposite 30 degrees, so we can say, sorry, the side S/2 is adjacent to 30 degrees, the angle. So we can say it is R cosine 30. And we know that cosine 30 degrees is just square root 3/2R. And multiplying by 2 on both sides, we'll get S equals to square root 3R. So yeah, we have shown this. So this would be our first answer for the first part. Let's head on to the last part. Okay, so now we just need to find an expression for the area of the shaded region. And we need to give our answer in this form where A and B are constants to be found. Okay, so to find the area of this, so I can see like two, I can see one sector and okay, let's see. Um, so Okay, all right. So in order to get this, we can, so to get this, we can subtract the area of the sector BAD from this area. So yeah. Okay, you know what? Let me use a different color. Yeah. So sector BAD, we subtracted from this area in black. So this area consists of this section. Okay, so to get the area of the section, we just need to uh, find the area of sector BCD. Okay, I'm going to use a different color. So BCD minus the triangle BCD. So we need to find, that's how we find that area. And yeah, okay, so yeah, wait, yeah, so let's find the area of the sector BAD first. Okay, so sector BAD. So sector BAD, so to find the area of a sector is just half r squared theta. That formula is also given in MF19. So you're right here, and theta has to be in radians. So half r squared, so BAD, that is r, so r squared, and then theta is we call so to find this, yeah. So we established that that is 30 and this is also 30. So this is 180 minus 30, which is 120 degrees. Yeah. So 120 degrees in radians, that is, okay, so wait, 120 divided by 180, that's 2 over 3. So yeah, 2 over 3 pi. Yeah, so it's just 2 over 3 pi. Yeah. So you'll get 1 over 3 pi r squared. So that is the sector BAD. Yeah, that's a sector BAD. All right, now we are going to find the area of triangle BAD. Okay, so triangle BAD. So you can see that it's an isosceles triangle. Uh, so, oh, we already know the angle, so we can just use half AB sine C. So half AB, so the sides AB, we're just going to take it to be the radiuses, so R squared AB, and sine C would just be the sine of the angle in between those two sides, so 120. So half AB sine 120 degrees. So this would be 2/3 pi times half. Okay, so you get square root 3 over 4 r squared. Yeah, so that's triangle BAD. And yeah, now we need to know the area of the black shaded region. So to do that, uh, we need to know the area of sector BCD. So sector BCD. Sector BCD, that is half r squared theta, so half s squared theta. So theta is okay, so yeah, it's this angle here. So this one we know it's just 60 degrees. 60 degrees is pi over 3, and s squared is 3r squared. So half 3, sorry, 3r squared times pi over 3. So the 3 cancels out, and then we'll get half pi r squared. Yeah, so this is sector BCD. Okay, now let's find the area of triangle BCD. So BCD, we need to find the area of the triangle. Okay, triangle, sorry, triangle BCD. So we can use half AB sine C. So A and B are just going to be these two sides as S, and then the angle would be 60. So sine 60. So half AB, so S squared sine 60 degrees. So 60 sine 60 is, sorry, sine over 3. So yeah, this is square root 3 over 4, and then s squared is 3r squared. Yeah, so you'll get 3 square root 3 over 4 r squared. Yeah. Okay. Yeah, now we are going to find the black shaded region. Yeah. I'm just going to write it as that. So that's just sector BCD minus triangle BCD. Okay. So that's the black shaded region done. So yeah, now we can subtract the sector BAD from the black shaded region and triangle BAD. So, okay, sorry. Uh, sorry. Okay, sorry for the delay, everyone. Yeah, so I managed to get my pen to work. Uh, yeah, so as I was saying, to get the area of the shaded region, you take the area of sector BAD minus the black shaded region minus triangle BAD. So that's what we're going to do. So shaded region is just going to be the sector BAD. So 1/3 pi squared minus triangle BAD. So minus square root 3 over 4 r squared minus the black shaded region. So that's minus pi r squared minus square root 3 square root 3 over 4 r squared. So that would be 1/3 pi r squared minus half pi r squared minus 1 over 6 pi r squared, and minus square root 3 over 4r squared minus negative 3 square root 3 over 4. That is square root 3 over 2 r squared. So, okay, now we're gonna switch the positions. Square root 3 over 2 minus 1 over 6 pi bracket r squared. So we factorized out r and we switched over the positions to make it in this form. So a square root 3 over 2 and b is negative 1 over 6 pi. Yeah, so this would be our final answer for this part as well as the entire question, and we have also come to the end of this paper. So I hope you found this video helpful. If you did, please make sure to like and subscribe and share it with anyone else who might find it helpful. If you have any feedback regarding this video or any future video ideas or what you want me to cover next, feel free to leave them down in the comments below, and I'll see you again next time. Okay, thank you.